Consider the following circle with a center 0 and a radius of 5 centimeters. So here we have a circle, center of 0 and a radius of 5 centimeters. T is a tangent to the circle. So T is a tangent to the circle. A tangent is a line that touches a curve at only one place. In this case, it's going to be P. So T is a tangent to the circle at the point P. We're told that the length of PS is 12 centimeters. So from P to S is 12 centimeters. And we want to find the length of RS. So from R to S. Well, first of all, it's important to note that the angle OPS, so OPS is a right angle, 90 degrees, because a tangent meets a radius at a 90-degree angle. So we have a 90-degree angle there. And it's also important to note that the length of OP, which is 5, is equal to the length of OR, which is also 5, because they're both radii. So they're radii to the circle. So they're both 5. So using Theorem of Pythagoras, we're going to find OS, which is going to be the hypotenuse. So we actually have a right angled triangle connected to our circle. And we're going to try and find the hypotenuse, which is from O to S, and then we can take off the 5 and we'll be left with RS. So I've drawn the triangle out here separately, and we know that the height of the triangle is 5, the base of the triangle is 12, and we do not know what the hypotenuse is. We know that part of it is 5, but we're just going to label it as h for the moment. So we're going to use our formula for Pythagoras' theorem, which is h squared equals a squared plus b squared. Or we could use our formula from our formula book, which is c squared equals a squared plus b squared. So it doesn't matter which one you use, so long as the h or the c is the hypotenuse, which is the longest side. So I'm going to label my triangle, so the h is going to be the hypotenuse. I'm going to label 5 as A, and I'm going to label 12 as B. So we have h squared equals a squared plus b squared. We're going to let a be 5 and b be 12. So we get h squared equals 5 squared, so the a squared becomes 5 squared, plus 12 squared, the b squared becomes 12 squared. 5 squared is 25, 12 squared is 144, 25 plus 144 is 169, so h squared equals 169. So h is going to be the square root of 169, and the square root of 169 is 13, so h is equal to 13. So from here to here is going to be 13, which means from O to S is going to be 13, but we're interested in from R to S, so we're going to say 13 minus 5 will leave us with RS. So 13 minus 5 is 8 centimeters. So RS is going to be 8 centimeters. A circle with a center 0 has a radius of 29 centimeters. So here's our circle, here's our center, and we have a radius of 29 centimeters. So from the center to the edge will be 29 centimeters. AB is a chord. So from A to B is a chord. So a chord is a line that cuts through a circle but does not necessarily go through the center. If a line cut through the center of a circle, it would be a diameter. So this is a chord. M is a point on AB such that OM is perpendicular to AB. So AB is perpendicular to OM. And OM is equal to 21 centimeters. So from O to M, we have a distance of 21 centimeters. And we want to find the distance of A to B. So this distance here, we're trying to find what is the length of the chord. Okay, so first of all, the length of OA is equal to the length of OB. So from O to A and from O to B, because they are both radii. So if we have a look at this diagram here, we can see OA is going to be equal to OB, because they are both radii, and we were told in the question that the radius is 29, so this is 29 and this is 29. So remember, AB is what we're looking for. We were also told that OM is equal to 21. So from O to M, we have a distance of 21 centimeters. So what we have is an isosceles triangle that is cut in half to form two identical triangles, both right angles, both with hypotenuse of 29, both with a height of 21, and the same base. We don't know what the base is, but if we figure out what the base of one of them is, we can multiply it by 2 to get the entire distance from A to B. So if we just take one of these triangles and draw it out separately, so we're going to take AMO. So AMO, so we're taking this triangle here on the left hand side, and we're just rotating it so that the right angle is at the bottom. So we know that the radius is 29, so from O to A we have 29, and we know that from O to M we have 21, so we have a base of 21 on our triangle, and we're trying to figure out what AM is. So this distance here from A to M. And if we find the answer to that, we just multiply it by 2 to get the distance from A to B. So we have a right angle triangle, and we're going to use the theorem of Pythagoras to find AM. So our formula for Pythagoras is h squared equals a squared plus b squared, or in our formula book it's written as c squared equals a squared plus b squared. So we're going to label what we have. So the 29 is the longest side, so that's the h, or the hypotenuse. And I'm going to label 21 as b. And AM, which is the side we're looking for, I'm going to label as A. So we have h squared equals a squared plus b squared. H is 29. B is 21. So the h squared becomes 29 squared. The a squared stays as a squared, and the b squared becomes 21 squared. 29 squared is 841. 21 squared is 441. Bring the 441 over the equal sign to become minus 441. 841 minus 441 is 400. So 400 is equal to a squared. So the square root of 400 will give us a. So the square root of 400 is 20. So a is equal to 20. So from A to M, we have a distance of 20. So we're going to multiply that by 2 to get the distance from A to B. So if from A to M is 20, then multiply that by 2. 2 by 20 is going to be 40. So the distance from A to B is going to be 40 centimeters. So AM was 20 centimeters. AB is 2 times 20 centimeters because M is the midpoint of AB. So M is in the very middle of AB. So AB is equal to 40 centimeters.